need to know that. I have 3 daughters. I had all brothers, but it's different, you know, having daughters because you experience them differently. And I have this biology student come in, and he's, am I going to die if I eat moldy strawberries? And I look at him. Yes. Cully did this, and I looked at him and I go, why? And he goes, well, some kid dared me and I ate moldy strawberries. And I go, why would you do that? And see, that's a guy thing, because girls would look at you and go, you eat them yourself, you know? We're like, you're crazy. But guys, you know, that's like oh, he dared me. And this kid asked me this, and I looked at him and I go, is it that easy? I dare you to be a missionary. You know? And he just looks at me and I'm like, what? So I'm sorry. When the guys always come up with these kind of questions, and I kind of look at you guys and go, why? So any of these that you want to take home and you know, play with, we'll go from there. But I can't say I'm sorry. It always makes me think of him, though, with the moldy strawberries. And yeah, why would you want to do that? Guys, when somebody dares you, just look at them and go, just laugh. You go, I don't think so. See, girls, it's easy for, isn't it, ladies? We just look at them and go, you're crazy. No way. So, all right, we're back to units. Now we were talking about moldy food. We'll do that next year. That's in biology. Let's do units. When we measure matter, we have to be able to explain what it is we're talking about. And on page 8, he actually gives us the example that if you measure the curtains and you don't say whether it's in inches or centimeters, you could get some very odd curtains, couldn't you? So units are very important. I can give you a real easy example. If I owed you $100 and you said to me, you owe me 100, and I gave you 100 pennies and said, well, you're paid, you'd go, oh, it was $100, not 100 pennies. Oh, but you just said 100. You didn't say what. I could give you 100 rocks. You know, you have to distinguish what it is you're talking about. It's very, very important. And he gave the example here of the Boeing 767 flight that actually ran out of gas because they were using different units, and they didn't know that because they hadn't written down the units. So your units are extremely important. What do I mean by units? On the bottom of page 9, the units are the physical quantities names that we use. When we measure mass, we measure it in grams in the metric system, and we measure it, believe it or not, in slugs in the English system. Even though we think of mass as being weight, it's really not weight. And that's why we don't use pounds, even in the English system. Weight is actually how strong the gravitational force of a body pulls on the mass. Which means, are you guys aware that the gravitational pull on the moon is less than on Earth because it's a smaller astral body? Okay? Which means my mass is how much it makes me up. My weight is how much the gravity pulls on my mass. So if I stood on a scale here, I would get depressed, but I would weigh one thing. Okay. And then if the Enterprise from Star Trek beamed me and my scale to the moon, I would look like I had lost a bunch of weight, wouldn't I? Yay! The problem is my mass would remain the same, so my clothes would fit the same way. So the point is that mass is how much matter there is that makes something up. Weight is how much the gravity pulls on that. And because of that, you see mass in the metric system is in grams, and in the English system, it's in slugs. I know, not to be confused with the little guy that comes out of the rain, right? Okay. And I think this is the only chapter you'll ever have to know that in this class, the slugs thing. Okay, so just, you'll get through it. The next one here is distance. Now, if we're measuring distance in the English, which is the normal stuff for us Americans, we'd do it in feet, wouldn't we? We'd use a ruler, we'd measure it in feet, we might measure it in yards, we might measure it in miles, depending on what we were measuring. And that can get very confusing, like, how many feet are in a mile? 5,280. And I only know that because I just prepped for chemistry. Otherwise, I wouldn't know that. Because it's not the kind of thing that stays in my head, because the English system can be very difficult. All of us know how many inches there are in a foot because our math books tortured us with it. And how many feet there are in yards and things like that. But this system is more difficult. The English system that we use is more difficult, and scientists worldwide use a metric system, and that way everybody knows what they're talking about, and so within the scientific community, everybody uses the metric system. And you know what? I'm glad they do, because it's easier. You multiply by tens. I can move zeros. It works. It's much easier. So it's all good, but we need to learn. So the distance for the English system is a foot. The distance for the metric system is a meter. That's a meter stick. So that's a meter. And to give you, so that you can understand the scale, right here would be the end of a yard. So I want you to notice that the meter is just slightly larger than a yard, isn't it? Okay? So this is the base unit that we use for distance for the metric system, and we use the foot as the base unit for the English system. And then for volume in the English system, we use gallons, and that's why you still buy gallons of milk or half gallons of milk or half gallons of ice cream. We use gallons. Now, any of you that have ever done conversions on volume in the English system know it can drive you crazy. Okay? Like, how many tablespoons are there in a cup? How many cups are there in a quart? How many cups are there in a gallon? Ah! You know, and you sit there multiplying all these weird fractions trying to figure it out. I know, because I bake, and I do it all the time. And so it's enough to drive you crazy. And the metric system, like I said, it's all working with zeros. You know, you multiply by 1,000, or you multiply by 100, or you divide by 100. It's fairly simple comparatively. For volume on the metric system, though, and a lot of people are less familiar with this than they are a gallon, we use a liter. This is a liter beaker. And so this would be a liter. Now, most of you are semi-familiar with liters because we buy 2-liter bottles of soda or whatever. You might buy a liter bottle of water. And a liter is right around a quart. So, and if you're going, I'm not sure what a quart is, just let it go, okay? So, this is a liter. Okay, and then I want you to notice for time, we all use the same thing. We use seconds. That's nice. That's nice. We only have to know the one for that. So you do need to know that he's going to ask you on the test, what's the metric unit for mass? And what are you going to say? Grams. Right? They're right there. Do you guys see it right there? On table 1.1? Okay, good. Does everybody see that? I know I probably didn't say that one. You need to know, I'm going to ask you again, you have to know this for your test. How do we measure mass in the metric system? Grams. What's the basic unit to measure distance in the metric system? Meters. What's the basic unit to measure volume in the metric system? Liters. And what do we use to measure time in both systems? Seconds. What do we use to measure mass in the English system? Slugs, little squishy guys on the sidewalk. What do we use to measure volume in the English system? Gallons. And what do we use to do distance in the English system? Feet. Okay, so those are the basic units. You must have those memorized for this test. And we need to have a feel for the metric system because it's a science class. We're going to use the metric system. Turn to page 10, please. Okay. Now, I just explained to you about alternative units that if we were to measure this room, we would probably use our ruler and we would measure this room in feet. But some of you know that I live on the other coast of Florida. And if I were measuring the distance from here to my home, I would not want to use this. I would not want to measure it in feet. I want to measure it in miles. Shoot, even to your house you'd want to measure it in miles, wouldn't you? But to my house you'd really want to measure it in miles because I live about 200 miles from here, okay? So there are alternative measurements that we use in the English system because it doesn't work like the metric system, so we have to have, just like we have cups and we have gallons, etc. But in the metric system, it's easy because we just put prefixes on. You guys all know prefixes are the part at the beginning of the word. And so on page 11, he gives you here the prefixes that are used in the metric system. You do not have to know all of them. You have to memorize the 3 that are bolded. Does everybody see the 3 of them that are bolded? Okay, so if you see a little m in front of grams, and it would represent milligrams, then you would know that it's small. I'm going to show you this. Let's use liters because I have all these lovely aids here that I can show you. Let's use liters, okay? The 3 that you need to know are milli, centi, and kilo. And believe it or not, those are the same ones the chemistry students have to know. Those three. So you just need to know those. Does anybody here know how many years there are in a millennium? Yes? 1,000. So milli is 1/1000th. That's what it means. How many cents are there in a dollar? 100. So this means 1/100th. You guys knew that, right? Okay. Be scary. And then kilo means times 1,000. Actually, each of these is what it means. That's easy, right? Milli, 1,000th. Centi, 100th. Kilo, you need to remember, is big. It's times 1,000. Okay. So what does that look like? Here's a liter. Here's a milliliter. If I fill this up, you guys have seen these before, I know you have. If I fill this up with water and do this 1,000 times, it would fill this, and it would make a liter. If I took this little guy, this is a centiliter. I could fill this up 100 times, and it would give me my liter. A centiliter. Okay? And if you wanted to see a kiloliter, we'd have to have a hot tub. And we just do this 1,000 times. All right, so you can feel, kind of get the feel for this. We said that a meter is this long. If you were measuring your textbook, the meter stick wouldn't work, would it? You would want to use centiliters, wouldn't you? And so you would use these centimeters. And you'd use, I got it. You'd use the centimeters across here, wouldn't you? That would be the best to use for that. And if you were measuring an ant or a gnat, you might want to use millimeters, wouldn't you? These little lines on here to measure him. Although you'd be an awfully strange person, but we won't go there. Okay, it's just an example. And then what if you were doing one of those 5K runs? Well, then you're measuring it in kilometers, because you want the bigger distances. Does that make sense? Okay, so you can see how this is a fairly easy system. Now, I do the converting differently than Jay Wiles does, so I'm going to show you my way. And then as long as you do it right and you show all your work and you always have units with your numbers, that'll be fine. But I'm going to kind of suggest you consider my way unless you're just absolutely fixed on your way, because my way works all the way through physics and chemistry. Okay, first off, some of you looked at this section, didn't do the written work because you said, I can do all this in my head. If you do it in your head on your test, it's going to be counted as wrong. This is not a math class. This is a science class. You are being taught the procedure that is more important than the mathematical answer. And so it is absolutely imperative that you write all your work down. Don't do it in your head. Number two, you are not allowed to do these problems in your head or by hand. You must use a calculator. I'm telling you right now, you must use a calculator. So if you don't have one, get one. And tell your mom I said you're not allowed to do them by hand. You have to do those in your math class, not in your science class. I want no problems because you have arithmetic problems. That's not our job here. Our job is science. And so you use the calculator to do the actual arithmetic, but you have to write down your setup. You have to write your units, because that's a part it's important that I know you know. So far, so good? So if on your test you just got a little number there, it's going to be all wrong. And on your test, if you have everything written out, but your answer's wrong, but you have everything else perfectly, and your units there, you're going to get most of the credit. Because that means to me you can't punch a calculator. Okay? Which happens. Don't laugh. So make sure you do all your answers twice on your calculator. Your parents don't do their checkbook once, trust me. Okay, make sure you do it twice so to make sure that your answer is correct. Now, let me show you how I want you to do these. Turn over to page 14, please. Let's look at the on your own here. There's a process here that I want each of you to do. You can either just do this process or you can write it down. First I'm going to tell it to you, then I'll write down the steps because it's imperative to me that you know these. These steps work for any word problem, mathematical word problem. So all the way through calculus you can use these steps. All the way through physics you can use these basic steps. I'll tell you when the basic steps end and we go into the conversions, okay? First thing, pray. Always pray before you study. Always pray before you do your homework. Always pray, 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 pray. You know, we're supposed to be in prayer constantly, aren't we? Pray continuously, that's what it says. Always pray before you study and pray before you do them. And when you see a word problem, you want to stop and pray again. Okay. Number 2. Some of us really understand that. Number 2. You want to always read a word problem twice. The first time you read the word problem, you're reading it so your brain can go, ah, I'm doing a word problem. Okay, and then you get over the shock after you've read it the first time, and then you're going to read it again. And the second time you read it, you're going to be looking for what I call the given and the get to. The given and the get to. The number that we're given, the information that you're given, and whatever you're trying to get to. When you find those two things, you're going to write them down. You're going to write both of them down. I'm going to show you this in a minute. Then, if you're doing other types of math, you might have an equation or a formula that you've memorized. At this point, if you're doing that, you're going to write down your equation or formula, and then you're going to try to start plugging things in. Here, on these conversions, it's real simple. Once you've got your given and your get to, you're going to write your given again, and you're going to write times line, and then I'm going to show you this. Let me show you. Okay, so let's read 1.3, and is it your turn to read, Solomon? Because Mariah, you read last, right? Solomon, would you read on 1.3 on the left-hand page for me, please, sir?
A student measures the mass of a book as, what is that?
12,321.
12,321 gallons.
Grams, that's grams.
Right. What is the book mass in?
That would be kilograms. Thank you very much. Okay, so everybody, we've read it. Our brain is hyperventilating, but we're going to calm down. Okay, now we're going to look at it again, and we're going to find the given and the get to. What's the given? Somebody tell me, what's the given there?
Or that the book is 12,321 grams.
Perfect. That's the given. What's the get to?
Given to kilograms.
Thank you. I just wrote down my given and my get to. That's your second step. Right? First step, read it once. Second step, read it the second time, find your given and your get to. Write it down. I'll give you credit for getting that far. No excuses. Okay? Next step. Next step. This is also true in chemistry. I just went through this with them. There's certain steps you just take. Okay? Next step. You're going to write the given down again. Because that's what you have to start with. So go ahead and write it down again so you can start to play with it. Now these conversions, when you're working with conversions, the next thing to do is to write times line. And the next one we do, I'm going to ask you, what do I do now? And you're going to all say times line. Say times line for me. Thank you. I had a chemistry student this morning. I go, does anybody remember from physical science what we do here? He goes, times line. I go, right. Okay. This is really important. So you're going to go times line. Now, any whole number actually can be written over a 1, can't it? So I could actually go like this, legally, couldn't I? Right? Yes. What can I multiply anything by and it will retain its mathematical value? 1. I can multiply anything by 1 and it'll still have the same mathematical value, won't it? That's a cool rule. Especially because I have this powerful trick, and so do you. We can make some pretty funky looking ones. And I call them funky ones. Now, what's a funky one? Well, in a fraction, as long as what's in the numerator equals what's in the denominator, it's really a 1, isn't it? If I were to write 60 seconds over 1 minute, that's actually a 1, isn't it? Because those two values equal one another. If I were to write 1 month over 30 days, work with me here. I know there's shorter and longer ones, but generally. That would be a 1, wouldn't it? If I were to write 365 days over 1 year, that would be a 1, wouldn't it? There's some weird looking ones, but they're ones. And I can multiply things with them, and it doesn't change the value, but boy, can I get some weird looking stuff. So far, so good? Is everybody tracking? What we're going to do here is we're going to make some funky ones. That's how we're going to do our conversions. He calls it the factor labeling method. It's actually dimensional analysis long term, so that's what I'm going to call it. Sounds a lot cooler too when your little brother or sister's bothering you. You go, please, I'm doing my dimensional analysis. Sounds very cool. Dimensional analysis. Okay, so what do we do here? We need to make a funky one to multiply this by. And we don't want to lose our value, but we want this to look like kilograms when we get done, don't we? So I want to make this a 1. Now, for this to cancel, what has to be down here? Grams. So what, and this, I just did this with chemistry, whatever unit is here has to go here. Not the number, just the unit. We tracking? Has to. So that you should be able to get this far just because you memorized it. Even if you don't understand it, you should be able to get this far. Okay? Now, where are we trying to get to? Kilograms, right? So I'm going to put that here. Why did I do that? Because then when I get done, the grams cancel and I'm left with kilograms. I just set up my funky one. This is going to be my funky one right here. Now this is where I'm different than Jay Wiles. I don't like fractions within fractions. I think it's ugly. So my next question that I always ask is, who's the big boy here? Is kilograms bigger or is grams bigger? Kilograms is bigger. He's going to get the 1. That just keeps him from having fractions inside of fractions. So if he gets a 1, what does he get? 1,000. That's right, he gets 1,000. And then you're going to get your calculator out, and you're going to go 12,321 divided by 1,000. And the reason it's divided by is because this is under the line. So for those of you that might look at this and go, now what do I do? You put this number in, and if the number was up here, you would multiply it. But because the number's down here, you're going to divide by it. And so when you do that in your calculator, you're going to get this answer. The grams will cancel, and you'll be left with kilograms. Ta-da! And how'd we do that? We used a funky-looking 1. That's what we did. So far, so good? Let's try the next one. And would you please read, what are we on, 1.4?
The glass contains 121 liters of milk. What is the volume of milk in milliliters?
Thank you, ma'am. So we have 0.121 liters. That's our given. And what's our get to here?
Milliliters.
Good, milliliters. Hey, she's not answering this by herself. All of you are involved. I need some participation here. Okay? So get involved here now. All right. Does anybody remember what's the next thing I'm going to do? Write your given again. Everybody say, write the given again.
Write the given again.
Thank you. So you're going to write your given again. Everybody, what's the next thing I'm going to write? Thank you. Everybody together. Times line. Okay, so we got times line. What unit goes down here?
1 liter.
Thank you. That's why I make my liter a capital L, so you don't get confused and think it's a 1. You notice that? I did it in milliliter too. It's real easy if you put M little l, it's real easy to mess it up. So make it a big L so it's real clear what you're working with, okay? So we got a liter down here. What do we put up here?
Milliliters.
Milliliters. Who's the big boy?
Liters.
He gets a 1. What's the other guy get? 1,000. If you will always ask yourself, who's the big boy, and give him a 1, they'll always get 1,000 except for centi, which will get 100. It's really easy that way. Okay? So ask who the big boy is, give him a 1. If it's not centi, centi gets 100. Everybody else gets 1,000. All right? That's nice. Until you get to chemistry, then they'll torture you, but that's okay. You got a few years before that. All right. And so what are we going to do here? Here we're going to multiply these numbers, aren't we? Because they're both on top. So we're going to end up with this. Because these will cancel. You're going to use your calculator, and you'll be done. How we doing? Would you read the next one for us, please, ma'am?
In the National Basketball Association, the distance from the three-point line to the basket is 723.9 centimeters at the top of the arc. What is this distance in meters?
Thank you, ma'am. So here's our given. They want to know the meters. I've written our given and our get to. What do I write next? Thank you. Write the given again. Whole class, what's next?
Times line.
Times line. Good job. What unit goes down here?
Centimeters.
Centimeters. Good. What goes up here?
Meters.
Meters. Who's the big boy?
Liters.
Good. He gets the 1. What's he get?
100.
Excellent. Drew, you're on it, man. That is great. All right. Does everybody see how that works? And then am I going to multiply or divide by 100? Good. I'm going to divide because it's below the line. Does everybody see that? So you're going to put this in. You divide by 100 because it's below the line. And then your centimeters will cancel. And you'll be left with 7.239 meters. I'm good with zeros usually. So when the other numbers get involved, I get messed up. Okay. So far, so good? All right, let's go on. the next thing we have to do is be able to go between the English units and the metric units. And that just freaks a lot of people out. You're going to do the same thing. You don't have to have the conversions memorized. You see that little table 1.3? Do you know what that table really represents? A bunch of funky ones. That's what it is. He's going to give you the funky ones. So if you still do what I told you, you're safe. So let me show you. It's 3 inches, and we want to know how many centimeters. We could have done it the other way, but that's okay. All right, then we get a whole new number, wouldn't we? All right, and so we're going to write our 3 inches times line, our inches down here, our centimeters up here. Next, you're going to look at your thing. What number is in front of inches on table 1.3? What is to the left of inches? 1. No, to the left of inches. 1. So right here on inches, you're going to put a 1 to the left of this too. What number is to the left of centimeters there? 2.5. You're going to put it here too. I've had students get this all set up and then put the numbers in the wrong places. I don't want you to do that. Whatever the number is to the left in the table, that's the number that will go to the left of that unit here also. Does everyone understand that? I would have never thought to focus on that until I saw students miss that, because then they got confused at that point. So I don't want you confused. Now we're going to we would take our calculator, we would multiply these two numbers together, inches would cancel, and we'd be left with, thank you, 7.62 centimeters. It's not hard, is it? Not if you know the process and somebody gives you the funky ones. And you write it down correctly in the first place, which I didn't do on that one, right? Okay. All right, let's try the next one. And so, Brianna, would you please read us the next one, darling? Oh, you don't have a book yet. Oh, I missed you completely. I'm so sorry. So would you please, she's going, that's okay, pass it along. Would you please read us 1.7?
How many slugs are there in 12 kilograms?
Thank you, ma'am. And so we have how many slugs? And we have 12 kilograms. What do I write next?
The given right again.
Good, the given again, which is 12 kilograms. What's next, class?
Times line.
Good, times line. What goes in the bottom?
1 kg.
Good, kilograms. Very good. What goes on the top? We're trying to get the slugs, so we're going to write slugs up here. Now we look at the chart. What is the number to the left of slugs on the table?
1.
So it gets a 1. What's to the left of kilogram on the chart?
14.59.
Good, 14.59. Now, what am I going to do with 12 and this number? Am I going to divide it or am I going to multiply it? I'm going to divide it. I'm going to put in 12 divided by this number. The kilograms will leave, and whatever number I get, that'll be the number of slugs. Does everybody see how that works? Okay, let's do one last one. Let's do 1.8, please.
If an object occupies 3.2 gallons of space, how many liters of space does it occupy?
Very good. Thank you, ma'am. So we're going to write the given, which is 3.2 gallons, and we want to know how many liters that is. What do I write now?
Write the given again.
Given again. Good. Times line. What dimension goes down here? What unit?
Gallons.
Gallons. What unit goes up here?
Liters.
Liters. Now we look at the chart. What number am I going to put next to liters?
3.78.
3.78 is what's on the chart. So that's what you want to put on there. What number am I going to put next to gallons? 1. Very good. Am I going to multiply or divide these numbers? I'm going to multiply these numbers. The gallons will leave, and I'll be left with a certain number of liters. Okay? But do you see the process? Okay, what he said.
Because the bigger number's on top.
We multiply because both numbers are above the line. If one of them was a denominator, then we would take the numerator and divide it by the one in the denominator. Because this line actually means divided by. That's what that line means, is divided by. So when you come across here and see that, if the number's down here, you're going to divide by that number. So you knew that meant divided by, but sometimes people look at the numbers and they're not exactly sure what to do. So that's why I wanted to go through that with you to make sure you knew which ones to do. Okay? Now don't move because we're not done yet, but I want to ask before we go on, do you have any questions on this part? So, did this help? Do you feel like this, you're going to be able to do these? It's not going to be a problem now. Okay, because you really have to be able to do these for us to go on. Now, what we're going to do is next week, we're going to do the one lab, and then I'm probably going to demonstrate the other lab for you rather than us actually having to do it, because you'll notice that you don't have to write up 1.3 in your syllabus. You'll notice that this week. But I'll probably demonstrate it for you because you do have to understand the concept of concentration. And you said you didn't have any questions. Everybody look at your experiment one last time. How blue is your water? May I? For the benefit of the online students. Everybody see how blue the water is? Has yours stopped yet on the blue side?
I think so. All the blue like bubbled off. Like it's sort of blue. It's not like.
Well, compare it to the other side. The other side's kind of blacker and that side's bluer. Okay, because it's a comparison. Oh, one other thing on your test. If you want to say it's copper colored, you can say brown, reddish brown, copper colored. If you want to say it's blue, you can say blue, turquoise, teal, green. Just make sure it's the general idea so I can tell you know what you're talking about. Okay? All right, so next week you're going to finish the chapter. You're going to write up your lab write-ups up to the part where we do them together, the one you're supposed to do. Complete this one. Follow the syllabus. You're going to hang on just a sec. Stop moving. You're going to do your study guide. If you have problems, it's okay. We're going to go through it together. Do not take the test. You will not take the test till after next week's class when we go through all this together. We make sure you're on track, having just up to speed, no problems, and then you'll take the test. Okay? Any questions? All right. Have a Jesus-filled week.